All right, well, welcome everyone. My name is Steve Cross, and I am a retired or emeritus professor from Oklahoma State University, where I was in the civil engineering department. And basically was the asphalt professor. And I have been serving as the technical director of the Asphalt Recycling and Reclaiming Association for the past 8 to 10 years. And we're a trade association that's made up of contractors, suppliers, and consultants or engineers that work with in-place recycling. So what we want to do today is give you a little introduction on cold in-place recycling, one of the in-place recycling techniques. So this is not a new process, even though you may not have heard it, but it's been around since the early 1900s. But it wasn't until the energy crisis of the early 1970s, and at the same time they developed the large-scale cold planers or milling machines, and that's what kicked interest back up in cold-in-place recycling. So the state of Oregon, New Mexico, and Pennsylvania were some of the early champions, and then Kansas jumped in right behind that. And so this was in the 1970s and 1980s. But there's been some tremendous improvements in cold-in-place recycling, and one of the biggest ones was the development of engineered emulsions, and then improvements in the equipment, including the development of the single unit train that we'll talk about, and not necessarily the development, but the use of foamed asphalt as well. So as far as what we want to cover today, we want to understand the basics of cold-in-place recycling construction. We want to gain a little perspective on where it should and should not be used. There are differences in the equipment or trains, so we'll talk about the difference between the single unit and the multi-unit trains. We'll talk a little bit about the recycling agents that are used and their differences in performance. And then there's some additives that we can add to improve properties, and we'll talk about those. And then real quickly or briefly, we'll talk about some of the documented CIR performance to give you an idea of how this stuff works. So to start with, ERA and FHWA classify cold recycling under two types. There's cold central plant recycling that we have another course on, and cold in-place recycling, which is also called partial depth cold in-place recycling. And the reason I threw this slide up here, a lot of people talk like there is a difference between cold central plant recycling and cold in-place recycling. And really the only difference is one is processed at a central location, the other is processed on the road. But other than that, there's really no difference in the mixes. So just what is cold in-place recycling? Well, I'm going to take a distressed pavement and I'm going to turn it into a new pavement using a train of equipment. And so what that train of equipment is going to do, it's going to mill the deteriorated pavement, typically 3 to 4 inches, but we have seen people go 5 to 6 inches in a single pass if you can get the compaction or the density, but 3 to 4 is much more common. We mill it up to make reclaimed asphalt pavement or wrap. Then we're going to size that wrap. Usually just try to keep it under a maximum size. We're going to mix it with the recycling agent. Then we're going to repave the recycled mix. We're going to compact it to a specified density, and then it's ready for a surface treatment. It will require some type of wearing surface. And again, all of this is done in place on the road with little to no hauling in of materials. As far as project selection, now this is just a tool in your toolbox. It doesn't work everywhere, but there's some places it works exceedingly well. So cracked pavements with stabilized bases are some of your best candidates for cold in-place recycling. We're only going to treat down to a depth of say 3 to 5 inches. So distresses that occur deep in the pavement, or if you have base issues, cold in-place is not going to treat that. Where it works best is cracked pavements or reflective cracking, because the more of the crack you remove, the less likely it is to return. So cold-in-place recycling gives me a very cost-effective way to remove a lot of that existing crack and preventing it from returning back through as a reflective crack. A couple of other just things, geotextiles. We can recycle a road with geotextiles in it, but we want to make sure we mill through it. And if we're not going to mill through it, we want to be sure we stay about 1 inch above it. The one thing we don't want to be doing is grabbing that geotextile with the teeth and not going through it and ripping it up. If we have poorly bonded or delaminated layers, I want to be sure I mill through that. That will stop me from slabbing or getting chunks coming out that we'll have to deal with. And then if I have pavements that have other than major or deep structural issues, besides just cracking, they can be successfully rehabilitated with cold-in-place recycling. We want to be sure we have a proper mix design. If we have a stripping problem or a rutting problem, we want to be sure we handle that in the mix design. And we want to make sure we have an adequate overlay to be able to handle the anticipated traffic. So it's a very, very versatile product. So real quick, just kind of to show you the way this works, we've got a distressed pavement with an aggregate base and native soil, or we have a full depth asphalt pavement, either one. So I'm going to take a recycling train and I'm going to run through there and I'm going to mill off the pavement. If I have a good stable base and a thin asphalt section, I can actually go down to that stable base. But if I have native soil, we generally recommend that you keep about 1 inch of material or 1 inch of asphalt on there to help support the equipment. That milling machine is heavy, and we do not want that breaking through while we're processing the equipment. The other thing to realize is that milling machine is what's pulling everything else. And so we want to make sure we have enough structure there to support the loads. There are different types of equipment. So what you see a lot back east, and these are some of the newer ones, are the single unit CIR trains. And so basically what they are is a milling machine that's had some very slight modifications so that I can mix the material in the cutting housing. So up on the upper one, you see one of the manufacturers, and that one happens to be laying the material in a windrow, which is going to be picked up with a windroll elevator and paved. And down in the bottom, you see one that has an attached screed to it, so it will place the material directly. You also see in the bottom on that paver, there's a ski attached to the paver. And using the ski goes a long way to helping you get a nice, good, smooth product. So those are the two single unit trains. And in a single unit train, inside that cutting house, they've made some slight modifications, but it works in a down cutting mode. And so it's going to grind the pavement up in a down cutting mode. It's going to stay in the asphalt. It's not going to get down into the subgrade. And we're going to add a new spray bar in there because there's already one in there for water to cool the teeth, but we'll add another spray bar to either introduce foamed asphalt or emulsified asphalt. So all the mixing takes place inside that cutting chamber. And then there's multi-unit trains. You see more of those out west, although there are some of these on the East Coast as well. But the multi-unit train consists of a full-width milling machine or cold planer, typically 12.5 foot wide cutting drum. It's going to mill the material full lane width, and then it's going to take that material and dump it over a recycling unit. And that recycling unit's going to screen, crush, and then mix the material. You can see in the upper picture, that's one manufacturer, the lower one is another one. It's pulling a tanker behind it that has recycling agent, and it'll either be pushing or pulling another tanker that has water. So these can end up being 4 to 5 pieces of equipment long, and that's where it gets the word train. They're not quite as maneuverable as the single unit trains because they're just a little bit longer. As far as how they work or the material flow, you see on the upper part there's the milling machine with a cutter drum. It's going to mill the pavement. It's just a cold planer. We're going to, and it's going to operate in a down cutting mode more than likely as well. It's going to take those millings and it's going to drop them over a series of scalping screens. And we'll be screening. The oversized will go to a crushing unit, which then gets returned back to the screening deck. So the nice thing about the multi-unit train, it's a closed loop crushing and screening unit, so I can guarantee the maximum size of my wrap. And then that material is going to drop through the screening deck and into a pug mill where it's going to be mixed with either foamed or emulsified asphalt and then dropped on the road where we'll pick it up with a windrow elevator and pave it. So as far as that third step, that's sizing the wrap and mix the materials. So it's done a little bit different. If I have a single unit train, the only way I can control the top size of the wrap is with working that drum in a down cutting mode and by controlling the forward speed of the unit. The slower I go and the faster I spin the drum, the finer the material. So again, I cannot guarantee you a maximum size with the single unit train, but I can control it fairly well. What we generally see is a spec of like 95%, allow a little bit of oversize. If I see a big chunk that comes through, you have a couple of choices. You can toss it out, or you can pick it up and throw it back in front of the machine. But it does a good job of controlling the maximum size. It's going to add the recycling agent in based on volume and the forward speed of the unit. So we have to assume an in-place unit weight of the material, and then we know the depth and width of the cut, and then the pump is hooked up to the forward speed of the machine. So I can input my recycling agent. I can guarantee that I'm going to get the right gallons per square yard. But being able to get the exact percentage is a little bit of a guess because I'm guessing the unit weight of the material. Still does a very good job. And then Word can develop the single unit and Word can promoted foam. So there's kind of a thought out there that single units use foamed asphalt and multi-unit trains use emulsified asphalt. And that's simply not true. They can use either one. They can be set up to use either one. Now, it may be true that your contractor is only set up to use one or the other and hasn't paid to have the extra spray bar put in or modified his machine. So they may not be able to use either one, but it is possible. As far as the multi-unit train, these are a little more precise just because of the closed loop system that's on there. So we're going to control the top size of the wrap with a crushing and screening unit. So you can see up at the top, the material's coming off the cold planer and it's going over a screening deck. And any of the oversized material will go through a crusher, be fed back through. And then it all drops into a pug mill. And so there's a weigh belt that's going to weigh the material going into the pug mill. So I'm going to add the recycling agent based on the mass of the material entering the pug mill. So I can put that in much more precisely. And again, it just depends upon what spray bar you happen to put in the pug mill as to whether you can do emulsified asphalt or foamed asphalt. Now the multi-unit trains have been around a lot longer than the single unit trains, and they traditionally did emulsified asphalt. So that's where that thought comes in that multi-unit trains use emulsified asphalt and single unit trains use foamed asphalt. But again, they can be configured to do either one. As far as mixing, we're going to mix these things with water and a recycling agent. We'll use some recycling additives sometimes if necessary. The two recycling agents we use are both bituminous products. We're going to use emulsified asphalt. And by far the most common is an engineered emulsion. And we use some polymer modified emulsions. An engineered emulsion is typically a CSS1 cationic emulsion that's been modified with the formulation just to fit the conditions at your site. So to control the braking, might add a coating enhancement and a few other things. And then the other one is expanded asphalt or foamed asphalt. And then the additives that we use, we might add a little bit of dry cement or lime slurry to improve your process. If you're not familiar with foam, it's a series of nozzles, and what I'm going to do is I'm going to take hot asphalt, and I mean hot asphalt. It's going to be 325, 350 plus, and I'm going to inject a little bit of cold water into a nozzle where that hot asphalt is. That water is going to turn to steam or vaporize, and that will cause that foam to expand in a lot of little tiny droplets. And be foamed asphalt. So that's how we make that. A lot of talk about which one's better, foam versus emulsion. They're different. So foam is a binding technology, and emulsions are a coating technology. So if you look up at the top, those two pills are from a mix design. And the one that you can see, the foam treated, shows a lot of little black specks through there because foam is a binding technology. We spray that foam in there. It comes in as tiny droplets. I like some fines in the mix to help disperse that material. And it basically like tack welds the material together. And then emulsion is just asphalt droplets suspended in water. So a typical emulsion might be 2/3 asphalt, 1/3 water. The emulsifying agent is what keeps it in suspension. And it's a coating technology, so it'll coat it, so you'll see a nice black pill. However, with time, if you look down on the bottom, those are 2 cores taken out of a test strip down at Auburn. And one was foamed asphalt, and the other was emulsified asphalt. And I don't think you can tell the difference. They're going to look the same. One of the issues with, not an issue, but one of the things with foam, to help disperse those droplets, you need some fines in the mix. So they generally recommend 5 to 20% fines or -200. And most 100% wrap mixes, and cold in place by definition is 100% wrap, is not going to have the fines. So it's very common to see about 1% cement added to a foam mix to help disperse those asphalt droplets. As far as the performance, the NCHRP 9-51 project was done by the University of Maryland and with VTRC. And they looked at the material properties of CIR and full depth reclamation asphalt pavements. And they cut a lot of cores, did a lot of lab tests, and could find no difference in the mixed properties between the foam product and an emulsified product. And then I went looking through the literature trying to see if I could find some test locations where they had compared both on the same road. And that's actually a little hard to find. But the best one was from Ontario, the Ministry of Transportation, and they placed a foam and emulsion CIR on the same project. It was Highway 7 in Perth, Ontario, if you're familiar with that area. And they published a report after 10 years of traffic on the road, and they couldn't tell any difference. They said both were performing quite well. So moving on, if we're looking at the additives that we might put in there, and these are becoming quite common. We can add cement or lime, and they can be added as a slurry. Or they can be, and if we're going to add them as a slurry, I want to inject them right into the cutting housing of the milling machine or the single unit train. If I'm going to put cement dry or add corrective aggregate, then these are usually spread in front of the milling machine, and the milling machines or the single unit's going to run over it and incorporate into the mix that way. We do have to be careful with some of the dry additives, especially in windy conditions. Dust can be an issue. What are the benefits of cement or lime? Well, one of the nice things about cement with a cationic emulsion or with the emulsified asphalt products, they tend to act as a catalyst, so they'll help them break a little quicker, and they'll give you some early strength. So they'll stiffen the mix up earlier, allow it to regain or gain strength quicker. And then it'll also act as an anti-strip agent, which would be helpful as well. And with foamed asphalt, we'll add the cement to help disperse the asphalt droplets, and it'll act as an anti-strip as well. So adding cement is common. Lime is not as common. It's typically added as a slurry, but it has been used as well. So as far as placing it, the CIR mix can be placed lots of different ways. You can see up at the top with the single unit train off to the right, there is an attached screed, and it can be placed that way. Some of the single unit trains have an attachment. You can attach the screed right to the plane. Most of the multi-unit trains will drop the material, and some of the single units will drop the material in a windrow. And then I will pick the material up with a windrow and drop it into Paver. The nice thing about the windrow is I can allow that mix to start the braking process and control when I pick it up and place it. And with some units, you can drop it straight into a paver and place it. And again, I want to point out, you see the pavers are using skis, which helps tremendously with getting a smooth process. And then one of the things we see people that are inexperienced with this is a cold mix, and it's hard to compact. And they think, well, if I heat the screed, that'll make it easier to compact. And it won't. All it's going to do if you heat the screed is make the mix sticky, and it's going to start sticking to the screen, and it'll drag and tear, and you're going to have a mess. So we do not want to ever heat the screed. We want to work it cold. Compaction. The mix is cold. It's quite viscous. It's hard to compact. So we're going to use heavy compaction equipment. So we're going to recommend that you have at least one pneumatic tired roller weighing anywhere from 22 to 25 tons. The higher the better. We want at least one heavy double drum vibratory steel wheel roller, 10 to 12 tons. And then we usually recommend a third roller, and that's at the contractor's preference, but we want at least one pneumatic and one double drum. They all have to have working water spray systems. The mix is not too prone to stick, but we want to be sure it's working and the mix won't stick to it. What we normally see, because these things fluff quite a bit when they come through, is they will come by, most contractors will hit it one or two passes with a vibratory roller, and then they'll get on it with a pneumatic roller and roll it until it walks out. And then they'll hit it again with the steel wheel roller to smooth it up. It's not always done that way, but if you use the pneumatic tired roller first, you're liable to bog down in it and get too deep a ruts and a little hard to come back out. So like I said, most people will hit it with one to two passes with the vibratory, then walk it out with the pneumatic, and then finish it up with a vibratory. And once we're done, at the end of the day, we're going to open that mix up to traffic. And we usually want to slow the traffic down and not have it go full speed if possible. And then we might want to protect it if we think it might ravel. So we can apply a fog seal to it to minimize raveling. And then if we want to open it up to traffic, I need to put blotter sand on that fog seal until it's cured out to soak up any excess fog seal. And then after I've done that, I want to release it to traffic. Now, one of the other nice things about putting down a fog seal and blotter sand is it tends to seal that surface off. A cold recycled mix is going to go down at high air voids because you're compacting it cold. So 8 to 12 to 14% air voids is not uncommon. Although using that pneumatic roller, it tends to seal the surface off pretty good. But if I apply a fog seal and blotter sand, and it's going to be several days until I overlay it, if I get a rain, that fog seal and blotter sand is going to help that mix shed water. So it kind of serves two purposes. It prevents raveling and will help shed water if it's going to get if it gets rained on. Then I typically like, especially with emulsions, I like to wait 2 to 3 days to let that emulsion fully cure out and let the water get out of there before I put an overlay on it. I don't want to trap any excess moisture in there if I can help it. So you'll see a lot of specifications say leave it open for 2 to 3 days, and sometimes they'll specify a residual moisture content. And that'd be, you'll see anywhere less than 2 to 3%. The only issue we run into that is if you're in an area that has a lot of rainfall, your in situ pavement may be higher than that. With foam, we don't always wait 2 to 3 days. Sometimes they'll cover it the next day, but foam does cure quicker than emulsified asphalt products. And then with an emulsified asphalt product, you have to put water in at the milling head. Then you have the emulsion. It's typically at or slightly above optimum moisture. So coming back at the end of the day or within a couple of days, you can re-roll that mix and sometimes pick up some extra density. So you want to be real careful with that supplemental compaction to make sure that you're not cracking the mix up. So we typically recommend don't try it unless the pavement's over about 80 degrees. And then we want you to do 3 or 4 passes on it to see if you're picking up any density. And if you're picking up the density, then you can do the supplemental compaction. It goes quite quickly, but you want to monitor it. And if you're not picking up the density, you see any cracking or roller checking or anything like that, you want to stop it. So it's something that we see. It's done a lot out west. It's not that common back on the east. And then as far as the final surfacing, again, as I said, this is a cold mix process. It's going to go down at higher air voids. Like I said, it's not unusual to see 8 to 12 to 14% air voids in these mixes. So I have to seal the surface to protect it. So what we like to see hot mix asphalt overlays put on these. The thicknesses just depend on how much structure you need. For low volume roads, we've seen chip seals placed on them, and we've seen slurry or microsurfacings for low volume roads, shoulders, and parking lots. But it does need to be sealed to protect it from moisture. Through this slide in here too, it also works in urban areas, even with the multi-unit train. So there's a thought that this developed out the central part of the country and out west, that it's something that we use on low volume roads. It can be used anywhere. It's been used on airports, interstate highways. It's been in rural areas, it's been in urban areas. So these are some pictures from Los Angeles, and they actually did cold in place recycling on Hollywood Boulevard through Los Angeles using a multi-unit train. The process moves quickly, so traffic control is not a big issue. And as far as utilities and vaults and whatnot, it's no different than any asphalt mill and fill process. So just threw that in there that it can be done. Moving on, we'll talk a little bit about performance studies. And there's a wealth of literature documenting the performance of CIR on all traffic levels. This has been used on interstate highways, it's been used on airports, it's been on low volume roads, major state routes. I would recommend if you're starting out, don't start on the interstate, start someplace else. But there's a wealth of literature from Nevada. New York has been doing this for 30 plus years. Iowa does a lot of it. Virginia is actually kind of out at the forefront, especially on cold central plant recycling. So there's the I-81 project, and then there's been a lot of stuff done at NCAT. There's the US 280 study. And MnRoad, to see how this stuff works in really cold climates, has put some down on their facility up there. So I-81, the right lane of I-81 was reconstructed using CCPR and FDR. The traffic lane or the left lane was in better shape, so they did CIR on that. And so what you see is they did a 5-inch CIR, and then they put 4 inches of asphalt on top of that. And at the time I put this slide together, it had been down for 9 years. It's been down a little longer than that. It had carried over 5 million easels and was performing quite well. There was no rutting, no cracking, and the IRI was in the 40 to 60 inches per mile, which is excellent. So it's been performing really well on interstate type pavement. And then at NCAT, they decided to see kind of how low could you go as far as an asphalt overlay. So they went out on US 280, which is a 4-lane divided highway outside of Auburn where NCAT is. The road had over 18,000 AADT with 16% trucks. And they put down 2 CCPR and 2 CIR sections, both 4 inches thick, over about 4 inches of old pavement. And then they put a 1-inch thin lay on top of it, which was a 20% wrap and RAS mix. And at the time I put this slide together, there's been more than 5 years of traffic, but the last report I saw, it had carried 5 years of traffic and 3.2 million easels. And again, this was put down expecting to fail. With that thin of an asphalt overlay, with that much traffic, they wanted to see how it would perform. And so cracking with all the sections is good. The rutting on one of the CCPR and the CIR sections are good. The 2 that are in the fair just dropped from the good to fair, so they're really not concerned about it. And the IRI has remained well. So again, we're monitoring these to try to get an idea of how thick of an overlay do you need over a CIR or CCPR section. And then MnRoad was what would go on up in cold weather sections. So they took the 70th Street, which is real close to the MnRoad facility. It was an existing road with 4 inches of asphalt on 6 inches of granular base and a clay subgrade, and it was in very poor condition. It was really probably more of a candidate for FDR than CIR. They put down some 500 plus foot test sections, and they have 2 3-inch CIR sections with a 1-inch HMA underneath it and a 1-inch thin lay on top of it. They did foamed asphalt and emulsified asphalt. The foamed asphalt had 1% cement in it. The emulsified asphalt section used an engineered emulsion, which didn't need it. It was put down in the summer of 2019. So we're pushing about 2 years of traffic on it. A report should be coming out soon on the performance, but what I've heard is they're performing well. And it's kind of an intermediate traffic, or low to intermediate traffic level road. So the estimated 20-year ESOLs is a little over 1 million. So in summary, cold-in-place recycling, it's an economical alternative to mill and fill and partial reconstruction. You're using materials that you've already bought and paid for, so it can be quite economical. We can see cost savings. They vary all over, but anywhere from 15 to 20 to 35 to 40% cost savings. It's sustainable. We're reusing 100% of the pavement in place and the wrap in place. It's going to greatly reduce trucking. If I'm doing a mill and fill, I'm going to have to haul all that material off, and then I'm going to turn around and haul it back in. So it greatly reduces trucking, which can put can help your surrounding roads, not running all those heavy trucks on it. And then it's also produced without heat, so it ends up being very sustainable. And finally, it has a good history of performance, like anything else though, if it's used on the right road at the right time. So with that, kind of an introduction to cold-in-place recycling, and I appreciate your time. Thank you.